This is the first of two videos in which I'm going to look at radical functions and how to graph them. You might notice that your textbook doesn't have anything for this. There is no 5.x, obviously, as a section. So this is something that's been added into the course since your textbook was made, and so it's something that I'm going over sort of outside of the textbook. So let's go straight into it. If you're taking notes, you're probably going to want some graph paper because we're doing some graphing. So what's a radical function? Similar to radical equations, this isn't a very shocking definition. A radical function is a function with a radical. So it's a pretty straightforward definition. But specifically, it's a radical with a variable inside of the root. So again, just having a root 2 or a root 3 or whatever isn't going to make it a radical function. You need to have a root x or something along those lines. And so we want to graph these things. Let's just go right into it with the most basic one possible. We're going to graph y equals the square root of x. We'll get to a point probably in the second video where we can do this sort of automatically, so similar to how we graphed parabolas. But for now, we're just going to go back to basics and we're going to make ourselves a table of values. All right, so we need some x values. We're going to use those x values to get some y values. But we're going to have to think a little bit more carefully. So your typical x values that you'd plug into functions, especially back in grade 10 when you were doing linear stuff, you probably would have done something like -2, -1, 0, 1, and 2. But if we stop and think about those for a second, these aren't really great options here. -2, we can't even do the square root of, so that one doesn't even work. The square root of -1 also doesn't work. The square root of 0 is fine, right? The square root of 0 is 0. The square root of 1 is 1, so those are both okay. The square root of 2, though, isn't a nice number. If you plug it into a calculator, you find out that it's about 1.41. So we only got 2 usable points out of our 5 here. The 1.41 is kind of usable, but if you're trying to draw a good graph, it's not the best choice. So these points are not the best options. What we need to do instead is think, okay, well, what x values could I plug in here that would make this actually work? What are your best choices? And these x values are going to kind of set the stage for what we're going to do in general here. So think about the fact that you're doing a square root. If you're trying to do the square root of something, what kind of numbers do you want to do the square root of if you're going to get nice answers? Well, the obvious choice would be perfect squares. Because perfect squares have nice square roots. That's what makes them perfect squares. So if we're going to make a table of values here, instead of using -2, -1, 0, 1, and 2, why don't we use 0, 1, 4, 9, and we'll throw 16 in there even though we're pretty much never going to use it just because it's too big. So if you do your square roots now, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and so on and so on. The square root of 9 is 3, the square root of 16 is 4, and so we got all nice values. So let's draw ourselves a graph. You'll notice that we don't have any negatives here, so instead of doing a full graph with all 4 quadrants, we're just going to do a graph that looks like this, just the L shape, and we're going to go up to 10 in each direction, just to fit some nice points on our graph. All right, so we've got our axes set up. Let's get some points on there. So we've got 0, 0, 1, 1, 4, 2, and 9, 3. So these don't make a straight line. So just like when we were doing quadratics, you might notice that this is going to make some kind of a curve. So do your best to put something that looks roughly like that through your points. It should be hopefully maybe a little bit smoother than that, but that's our general shape. And so there we go. That is our first radical function. Let's try another one. So we'll reuse the same graph. At least I'll reuse the same graph. You can do whatever you want on your notes. And we're going to graph y equals the square root of x, same as last time, but now we're going to throw a +3 out there. So let's think about this real quick. Our radicand is still just x. So we can actually just reuse the same numbers because the root isn't changing here. We've added something outside of the root, but that's not going to affect those x values. So let's make our table again. We've got x and y, 0, 1, 4, 9, and I'm going to leave off 16 this time. And so if we calculate our points here, we've got the square root of 0 plus 3 is going to be, well, 0 plus 3, which is 3. The square root of 1 plus 3 is going to be 1 plus 3, which is 4. The square root of 4 plus 3, and you can probably get the idea here, right? This is going to be 2 plus 3, which is 5, and so on. So if we put 9 in there, we're going to get 6. And so we get these 4 points. So let's go ahead and put those on our graph as well. So we've got 0, 3, 1, 4, 4, 5, and 9, 6. And so you'll hopefully notice that those points make the same shape. And so we should be able to put roughly the same curve through them. And we'll get something that looks like this, where you hopefully actually go through your points. All right. So let's try something a little different. What if it's not just x inside the root? So what if we wanted to graph, say, for example, y equals the square root of x plus 8? That's going to make things a little bit trickier here. So we don't want to make x be perfect squares. We want to make the radicand be perfect squares. So we're going to use values for x. That will make the radicand a perfect square. So you might have to think about that a little bit. Just target all the perfect squares you can and think about what x values are going to make those work. So if we want to make this thing be 0, we'd probably put negative 8 in there, right? Because negative 8 plus 8 will get us 0. If we want to make this thing be 1, we'd probably put negative 7, because negative 7 plus 8 is going to get me 1. And then the square root of 1 is 1, right? So we've got negative 8 plus 8 equals the square root of 0, which is 0. We've got negative 7 plus 8 equals the square root of 1, which is 1. Then if we want to make it 4, we would probably use negative 4 plus 8. Gets me the square root of 4, which gets me 2. And so we're targeting these same numbers, right? We want to get 0, 1, 4, and 9. It's just a matter of what you have to add or subtract to get there. So we're going to use negative 4. And then to get to 9, we'd actually just use positive 1, right? Positive 1 plus 8. And that's going to get me the square root of 9, which is going to be 3. And so here's our points. And you know what? Let's actually go one further. If we want to turn this thing into 16, we would do 8 plus 8, which is going to get me 16, which will get me 4. All right, so we're going to make ourselves a graph again. Let's make this one a little bit bigger. So this one's going to be a little bit annoying to draw. We're going to go from negative 10 on the left to positive 10 on the right, and then maybe just up and down to 5 and negative 5. So if you're graphing along at home, go ahead and sketch yourself out that graph, and then come back and we will graph it together. All right, so our first point was at negative 8, 0. Our second point was at negative 7, 1. Then negative 4, 2. 1, 3. And 8, 4. And so you see this has the same shape as the last one. It's just bigger because we did one more point to get that positive 8 in there. So we're going to go ahead and we're going to do our best to put a curve in that fits all of these points. And so we end up with something that looks like this. All right, we're going to do a few more, and then we're going to try to learn a way to do this a little bit faster. All right, so we're going to put 2 graphs on our next one. So we're going to do y equals 2 root x, and we're also going to do y equals negative 3 root x. So you'll notice, again, our radicands are 0, or sorry, our x, So our x values, we can go back to just using 0, 1, 4, and 9. And we're going to be able to do that for both of these. So if you do, just as an example, y equals 2 times the square root of, let's say, 9. The square root of 9 is 3. And so 2 times 3 gets me 6. The square root of 4 is 2, and 2 times 2 gets me 4. The square root of 1 is 1, and 2 times that gets me 2. And the square root of 0 is 0, and 2 times that just gets me 0. And so we're going to do basically the same thing on the other side, which is going to give me 0, -3, -6, and -9. So for your graph on this one, let's say go up to 10, down to -10, over to +10, and let's just go left to -1 just to have a little bit of something sticking out over there. So get yourself a graph that looks like that, and then we will put some points on it. And you know what, actually even try to graph these yourselves. So sketch yourself out a graph, put these points on it, draw the graph as best you can, and see how they compare to each other. And then come back and see what it looks like on my end. All right, so if I'm plotting my points, I've got 0, 0, 1, 2, 4, 4, and 9, 6 for our first graph. All right, so if we connect those, we'll get something that looks roughly like this. And then our second one also had 0, 0, and then 1, -3, 4, -6, and 9, -9. And that's going to look something like this. And so the shapes are similar, just one's a little bit more stretched than the other. And if you compare those shapes to the previous shapes, again, you'll see similar sort of curve, but these ones are stretched out more as well. All right, so what if I don't want to go through all of that process of plotting points and doing everything? What if I want to speed things up a little bit? Well, we're going to go over that in the next video. So for now, we're just graphing based off of points. But if you want to know how to do things a little bit faster, go ahead and look at the 5.x.1 video, where we'll go over how to shortcut things a little bit.